section 415 is titled Factoring Special Cases, and it's going to cover pages 9 and 10. Today we're just going to do page 9, and then we'll do page 10 next week. Okay, we're going to answer the question, how can I use the structure? And question 45 says, special quadratics. Factor each of the expressions below, if possible. Look for similarities and differences among the expressions and their corresponding factored forms. Be prepared to share your results with the class, then work as a class to sort them into groups based on patterns. What makes these quadratics special? Okay, so there are going to be some that follow a certain pattern, and we're going to highlight them if you have a highlighter with different colors. Okay, if you have your own calculator, you're going to want your own calculator so you can multiply some numbers, divide some numbers, add and subtract some numbers to figure out what the patterns are. Okay, so let's start with A. All right, for A, we have x squared minus 49. We are missing the x term. That means there's a 0x in the middle of that polynomial. Okay? When you're adding and subtracting, how do you get to 0? If I have 3, what would I need to add to 3 to get to 0? Negative 3. Those are what we call opposites. 3 and negative 3 would add to get 0. So we need to have opposites in order to get to our 0. So we're going to multiply our x squared times our negative 49, which means we want to get to negative 49x squared. So we need two terms that multiply to get to negative 49x squared, but add or subtract to get 0x. This one follows a special pattern where you can simply take the square root of 49 and take the square root of x squared. What's the square root of 49? 7. So we're going to have a 7x on one side, and the opposite of 7x is what? Negative 7x. 7x times negative 7x is negative 49x, and 7x minus 7x is 0x. So when we go to fill it into our area model, we're going to take the first term, which is our x squared, and our numeric term, constant, which is negative 49. And then we can take the two terms that we just filled in and fill in these two boxes. One of them was 7x, and one of them is negative 7x. So when we go to factor, it's super easy. What multiplies to get x squared? That's just x and x. What does x multiply with to get negative 7x? That would be negative 7. And what multiplies with x to get positive 7x? That would be positive 7. Anybody notice a pattern here? We have x plus 7 and x minus 7. These are just opposites, right? So we're going to highlight this one with a yellow, and that's going to be our x plus 7 and our x minus 7. Any others on this page that are opposites, we're going to highlight with yellow. Okay? All right. Problem B. We have a trinomial x squared plus 2x minus 24. If we multiply the x squared times the negative 24, we get negative 24x squared. We need factors of negative 24x squared that are going to add or subtract to get 2x. So we fill that into the bottom of our diamond. You think of the factors of 24. What factors of 24 will also add to get 2? Anybody think they know them? What did you think? 2 and 12 would either get you 10 or 14. 3 and 8 are also factors of 24, and so is 4 and 6. Any of those recognize that we'll add or subtract to get 2? How about 6x minus 4x? Our 6x times negative 4x is negative 24x, and 6x minus 4x is 2x. Okay? So you can try numbers like 1 and 24 are factors, 2 and 12, 3 and 8, 4 and 6. So that's why you should have your calculator out, trying your different factors of 24. All right, now let's fill in the area model. So the first term is our x squared, which we know factors to x and x. And our constant numeric term is negative 24. We know that this box and this box should be our 6x and our minus 4x. That means when we go to factor, x times a negative 4 is going to give us the negative 4x. And x times positive 6 is going to give us a positive 6x. So across the top, we get one of our binomials as x minus 4. And down the side, we get our other binomial as x plus 6. Any questions on problem B? All right. Problem C follows a slightly different pattern. We're going to highlight it with an orange or whatever second color you have. To get the top of our diamond, we're going to multiply our x squared times our 25x, which is 25x squared. What do you know about the number 25? It's a perfect square, right? 5 times 5? What's 5 plus 5? 10. But we have a negative 10 there. So let's fill in our negative 10x right here. So instead of them both being positive 5 and positive 5, they both need to be negative 5x and negative 5x. A negative times a negative is a positive, so negative 5x times negative 5x is 25x squared. And negative 5x plus negative 5x is negative 10x. Right? That's how the diamond works. All right? Now we're going to fill in our area model with our first term, which is our x squared. For x squared, we know it's just x times x. And our numeric term needs to be adjacent. So we're just going to fill in our 25 there. And then we know both of these go in here, so obviously order doesn't matter because they're the same. And then x times what is going to give us negative 5x. That would be our negative 5. And then same here, also negative 5. So our binomials are the same. We have x minus 5 and we have x minus 5. Okay, so far we have two patterns. This one was x plus 7 and x minus 7. This one, they're the same, x minus 5 and x minus 5. Okay? In your groups of 4, you guys are going to do D through I together. Go ahead and highlight F and H with your yellow highlighter and highlight D and G with your other color highlighter. And then we're going to do J, K, and L together. Okay, so let's do J. So to fill in the diamond, we're going to multiply our x squared term times our third term. So 4x squared times 25 is big. It's 100x squared. What do you know about the number 100? Does anything special multiply to get 100? What multiplies to get 100? 10 times 10, right? Okay, so let's see if that's going to add to get to our positive 20x. Would 10x plus 10x be 20x? Yes, so if it's a perfect square, always check to see if it's the square root. Okay? 10x times 10x is 100x squared, and 10x plus 10x is 20x. So this one works out really nicely when we fill in our 4x squared here and our 25 here. We're going to have perfect squares. The square root of 4x squared is 2x times 2x. We fill in our 10x here and our 10x here. And to get to 10x, we would multiply 2x times 5. Same thing with this 10x. We would multiply 2x times 5. So we're going to have 2x plus 5. And we're going to have a 2x plus 5, either way you look at it. That's why we're going to highlight this one in your second color. You have orange. Any questions on, is that J? Any questions on problem J? All right, let's try problem K. We're missing our middle term, just like we did up on A. What did we do on A? What did we write up on A? 0x. We need a 0x term in there, right? So we're going to multiply our x squared times 4, which gives us 4x squared. Our middle term is 0x. When we have 0x, we need what and what to go here. How do you get to 0? Right. A negative and a positive, they should be opposites of each other, right? So one of them should be 2x, and one of them should be negative 2x. But what happens? 2x plus negative 2x is 0x, but 2x times negative 2x should be negative 4x, right? But there's no negative sign there. This one is not factorable. We ran into a huge problem. Okay? So we can't do this, we can't do this, we can't do this. It's not factorable. Not by any method we know. There is a method we don't know yet. Okay. All right, problem L. Again, we're missing our middle term. So on K, we just wrote 0x, so let's write 0x again. That fills into the bottom of our diamond. And for the top of our diamond, we multiply 9x squared times negative 1, which is negative 9x squared. And again, we should have opposites that will get us to this 0x. So what's the square root of 9x squared? 3. You guys all see the 3 in there? And the x. So we should have one of them be positive 3x. And one of them should be negative 3x. Okay? 3x times negative 3x is negative 9x squared. And 3x minus 3x is our 0x. Okay? So when we fill in our area model, we're going to have 9x squared, and then the minus 1 over here. These two terms fill in the other diagonal. So we're going to have 3x and minus 3x. And then the square root of 9x squared is our 3x and our 3x. And then we would multiply 3x times negative 1 to get negative 3x. But we would multiply 3x times positive 1 to get positive 3x. So these are actually opposites. So we have 3x plus 1 and 3x minus 1. So we're going to highlight that one yellow because they're opposites. All right. In your groups of 4, you guys are going to do problems